Okay, so what is the ambiguous triangle? The ambiguous triangle is a scenario where you're going to have a side, and an angle. So this scenario is different than SAS. SAS has two sides and an angle. This has two sides and an angle. But what makes this different than SAS? The angle is not between them. Okay, that's the difference. Okay, got it? The angle is not between them. And then this ambiguous case gets tricky because now we don't know, does it produce one triangle, two triangles, no triangles? And that's what we're going to figure out. Okay, I would actually like to jump one page and then come back later. Okay, so go to this section. We're going to go into our calculator. We're going to make sure it's in degree mode. I want you to write down 6 of the trig values. So you're going to go into your calculator, sine 30 equals, and then write down the trig values, okay? And do that for the 6 of them. Okay, so here's what I got when I did this on my calculator. I don't know if you rounded it, how you rounded it. So here's 4 decimals, but if you did 2 decimals, that's what you should have. Everybody was good with that? Okay, so we have to discover what happened here. So I did the sine of 30 and I did the sine of 150 and they were the same. 40 and 140, those sine values were the same. Anybody discover what this relationship is all about? There's a pattern. Anybody see the pattern? I need you to really look at these angles. There was a 30 angle and then a 150. Okay, that made the same thing. 40, 140. They equal 180. Okay, so here's my rule. The sine of an angle will also be the exact same as the sine of its supplementary angle. So the sine of 30 will be the same as doing the sine of 150. Okay, so that's great. Now we're going to think about working that backwards. Okay? So working backwards, this time I gave you what I would call the trig value, right? And now I'm getting you to figure out the angle. So last time up here I gave you an angle and I wanted you to figure out the trig value. So this is working backwards. So how do you get angles? What's your button pushing? Inverse. So sine inverse okay, sine inverse it. Are you going to write me that 80 degrees is your answer? Okay. That's good, but you're only half right. Anybody have something else to add? There's another answer. Your calculator won't do it for you though. Or 100 degrees. There's 2 answers, but your calculator can't do that for you. Okay, do you want to test it? Go into your calculator and try, hey, well, what is the sine of 100? Yeah, it's the exact same thing as the sine of 80. So there's 2 answers, but your calculator never will do that for you. Okay? Okay, can you give me this then? Now you kind of know, hey, there's going to be 2 answers to this. Your calculator won't give you 2 answers. Okay, so all this creates a lot of confusion in this triangle situation. So this is why it's getting confusing, because now triangles could have some options instead of just one thing. Okay, do you notice that when your calculator gives you an answer, it would always give you the smaller answer? Okay, and the word for the smaller angle is going to be that word acute. You've probably heard it before. Acute means less than 90. Okay, and then there's always going to be another option, which is an obtuse one. Obtuse means bigger than 90. Okay, so here's the rules to follow with ambiguous. Okay, I'm going to always draw them the same. We're going to call this, whatever, the ground. I'm going to give you an angle. We're going to call this side, so I'm going to be giving you an angle. I'm going to give you this side, and it's going to be called the adjacent side, because it's beside the angle. And then you're going to be given the opposite side as well. Side, side, angle. So you're going to be given the opposite side, the adjacent side, and an angle. And then the unknown side. Okay? I didn't draw the opposite side in because there's going to be multiple scenarios for how it works. So you're always going to be going opposite side given, adjacent side given, angle given. SSA. Okay, here we go. Opposite side is, do we know what that symbol means? Greater than the adjacent side. It's going to make one triangle. Okay, so here's my ground. Oh, that did not go where I wanted it to go. Okay, so there's my ground. I don't know my ground. Okay, I'm going to give you this. Okay, so this is my angle. Okay, and then this is going to be my adjacent side. Okay, ready? If my opposite side is longer, here's what it looks like. Okay, do we agree right now I'm the same? So if I'm longer, I'm like that. Tell me where I can make a triangle. If I'm longer, how many times did I make a triangle? Just here. That was it. Once. Okay, so that's the rule. Okay, so if adjacent, so if you made something longer and you swung it around, guess where it would touch? Okay, it would only touch once. That's it. Okay, so now if the opposite side is shorter, if the opposite side is smaller than the adjacent, shorter, you have to do a sine law test. Two scenarios could happen. You could make an error in your calculator, and if there's an error, then you're not going to have any triangles, and if there's a number, you're going to have two triangles. So what does that look like? Okay, so situation number one on this. So here's my adjacent side. So if I go like this is shorter, okay? If I move this side around, how many triangles can I form? Can't. It's not going to touch. It has to touch that bottom ground, okay? So there's that scenario. Scenario number 2, this is shorter. We agree that that's shorter than the red line? Okay, ready? Here I go. If I move it around, boom, it touched. If I keep moving it, what happened? Touched again. Okay, so that's the scenario. It happened to touch twice. What kind of angle does this one form? Obtuse. Do you see an obtuse corner there? What kind of angle does this one form? Acute. So there's the situation where our sign could be 2 options. Okay, so ground angle adjacent. So my first was when this side was short, but then it was just too short. It didn't touch. I can move it around as much as I want, right? But it would never, ever touch. Ground adjacent so this time if I make my line shorter like this and I move it around, it could make a triangle that version, or it could have made a triangle that version. 2 options. Okay. And that's it. Those are the rules. So if the opposite side is longer, boom, no work. If the opposite side is shorter, we're going to have to test it out, see if this is the scenario or that's the scenario. Okay, here we go. Tell me 0, 1, or 2. That's all I want here. A is the angle, so that means side A is opposite. What is 8 compared to 10? Shorter. Less, shorter. So, do I write down 1 or should I test it? That's what I'm thinking now. I have to do a test, right? Okay, so 8 over sine 33. That's my AA pair. 10 over sine B. So you're going to have to do times, divide, sine inverse. You have to do all of those things. Times, divide, sine inverse. And all I care is, do you see a number or do you see an error? No. You're seeing a number out of that. So here's what I did. We were shorter. I tested it. I got a number. So my conclusion is 2 triangles get made. Okay, second example, identify the opposite side. So if this is angle A, A is opposite. What are we in relationship to 15? We're shorter than 15. Our opposite is shorter. So what should I do with shorter? I need to test. That's my test. My test is going to have me doing times, divide, inverse. I'm trying to get this angle. Calculator should be telling you there's an error. Okay, that's right. If you're wondering, that looks weird, that's what it will be. So there's no triangles in this one. So the drawing of it would look like this. That side was just too short. Okay, I'm going to identify the the opposite. So this is my opposite, 14. What is it compared to 12? It's longer. Done. Don't have to do anything. 1. Okay, yay, nay. Do you want me to do 3 more examples? They're all just the same thing. Or we're good with that? Just identify your opposite. So step 1, identify opposite. Talk to me if it's longer or shorter. If it's shorter, test, number or error. Okay, we're going to now do a whole ambiguous with the crazy 2 triangle case. Okay, so here's what we're going to do. We're going to go angle A, right there, 35 degrees. This is adjacent right over here, right beside A. Okay, this dash line is my ground. That's the side I don't know. Which number am I going to put for adjacent? Should I put 7 or 9 there? I should put 9 because A and A should be opposite of each other, right? Okay, so are you visualizing this? If this is 9, then 7 would be about that long. And when I could swivel 7, oh, it could have made a triangle there, or it could have made a triangle here. There's 2 options. Okay, so this is 7, or this is 7. I highly recommend highlighters. Okay, so I have 2 triangles here. Our triangle is going to have 9, 7, and question mark. That's one thing we're going to figure out. So there's one triangle. 9, 7, question mark. What's your other triangle going to look like? 9, 7, and question mark. Nine, 7, question mark. 9, 7, question mark. Okay. I want to make sure we don't make this mistake. There's a triangle here. Why would I not want to solve this triangle? Because it would be 7, 7, question mark. That's not my triangle. What does my triangle have to have in it? A 9 and a 7. Okay, do you see it? That's a triangle, but not for this situation. Okay, so here we go. Sine law. 7 over sine 35, that's a partner. 7 across from sine 35, pair, equals 9 over sine B. Okay, we know what we're doing. We're going times, divide, inverse. Times, divide, inverse. Go to 1 decimal place. Okay, if you wrote this down, great, you get half points. Why? There's a or. What's my or option? Okay, so here's what we're thinking. This angle is across from 9. Can you go into my triangles and say, across from 9, I have a blue triangle, and across from 9 in a pink triangle. So here's where I'm looking. Across from 9, blue is there, and across from 9 on my pink is there. Do you know where you would put what? One is obviously bigger than 90, and one is obviously smaller than 90. Can you see it? Okay, so that means I'm going to go small. This one's definitely less than 90, and this one is more than 90. Okay, so that's why that or situation is very important, because you have two triangles, therefore you have two angles. Okay, now we are going to finish. I'm going to go with the blue triangle here. Okay, you have a blue angle here, you have a blue angle here. Can you get me the last of the blue angles? So 12.5 degrees is my last blue angle. Okay, same thing. Can you get me my last pink angle, this whole pink angle at the top? So what are the other pink corners? 35 in that corner, 45 or 47 and a half in that corner. How is it going now? 12 and a half was the last angle there, but 97 and a half was the last angle there. We good with those numbers? Okay, final stages is, what's the last side? What's the last side? Okay, so I'm going to go blue. So my color coding here, I got my blue. So I'm going to use 7 sine 35. That's still the, you can use that original partner every time. Okay, I'm going to call this side C, because we already had an A, we had a B. I'm going to go side C1, because there's going to be two options. So I'm going to go C1, and I'm in my blue. What's the angle? 12 and a half is the partner, right? The pair. Okay. Finishing it, it's got to have a times divide. .64 side. Okay. Now I'm going to tackle my pink drawing. I can use 7 and 35 degrees again. That still works, because it's still in that. This time we are finding the side length, and it's across from 97 and a half. Okay, I'm done teaching. I just want to talk about a few things. I really encourage colors on this one, just to keep those ideas straight. Some people like charts. So you could be like triangle 1, A, B, C, A, B, C. You could be like that. You can make a chart. They both had 35 degrees. Angle B was 47.5, 132.5. Okay, you know what I mean? You could make a chart like that if you really wanted to. That's one idea. Okay. So there's one hint if you want, either colors, just drawing, or charts. And here's a deduction. What is wrong with this person's drawing? Who can point out why I would deduct them a drawing point? Why doesn't this not work out? Why is this not a good drawing? There's a concept error that they made. Something with this guy? Yeah. What's wrong with this one? I don't want to... You're right that that's the error. There's something we need to talk about with an angle. That's the concept. Is it making an error on? Obtuse. What would you say about that angle? What would you say about that angle? They're both acute. Can you make 180 degrees by adding acute plus acute? Would that ever work for you? No. So that's a drawing error. Do you see why then? Because this always have to add up to 180, and that wouldn't work out. Okay, so on your test, I would award you a point for your drawing, so make sure you understand that idea. I'm going to tell everybody here that if I could say where do people lose the most points on this first test, it's the ambiguous question. So make sure you're getting all your numbers down, okay?